Hello and welcome to the first Core Data Nuggets video. Today we're going to talk about the Core Data language. I'm Javers Lewis and I've been thinking long and hard of how I can bring some Core Data videos to the mix. And the one option was that I could record a 12-hour video that would have probably burnt my brain out as much as it would have yours. So I thought maybe I'll create bite-sized core data pieces of knowledge that you can dip in and out. And we're going to start with the scary language that makes up core data. So there's not a lot of coding today, it's just getting acquainted with what it means to speak core data, all the classes that belong to the framework, and we're going to dissect the master detail template because that's kind of got everything built in, and I can show you where these things are that we're going to talk about today. So like on the beer advert, how to speak core data. The classes that make up core data are manifold, and we're going to talk about a few of them. The first of them is going to be the NS managed object. The managed object is much like an NS object, the one that you've been creating many times over, and of course the managed object is a subclass of the NS object, but it can't be created like ordinary objects can. So normally you'd say new object, alloc, init, and then you're kind of ready to use it, or you're using the convenience method init with whatever, init with name and parameter xyz and so forth. That's not how managed objects can work. Managed objects need to exist in something called the managed object context, and hence there's another class, the NS managed object context. And this is kind of a key class. Whenever you're calling anything on an object, save the entire context or whatever, you always call that on the managed object context. This is going to sound a little bit alien, but all these classes kind of link in with each other. So they can't exist just by themselves. So a managed object doesn't exist on its own, and a managed object context also doesn't really exist on its own. Quick metaphor, imagine managed objects are guests that come over to your place for dinner. And the thing is, your place, say your living room, that's where the guests are. And imagine you're in this weird computer game where the guests are only in existence as soon as they hit your apartment. So the moment they leave, well, they can't leave. Your guests aren't outside your living room. They only exist in your living room. And your living room is the managed object context, and your guests are the managed objects. Sounds crazy. We're gonna see how all that works in code. To save all your changes, anything that gets saved to a persistent store file, and hence we have another class, the NS persistent store. You could even have multiple store files. So the store file is physically the thing that lives on the hard drive that contains all your data in whatever weird format core data saves it in. There can in fact be several. One of them is the SQLite store format. Another one is an XML store format. There's several others. There's an atomic store format. We're not going to be dealing with that. The one you're using on iOS mostly is the SQLite store format. That doesn't mean, however, that you can go and execute raw, low-level SQLite commands on that file. It may have worked in the past, but it certainly doesn't work anymore, and there's really no need to do that. Some people thought, hey, I already know SQLite, maybe I can find my way around it. Not quite the case, and not recommended by Apple, not encouraged, certainly not encouraged. But imagine this scenario that you had a store file and you want to save data. You kind of have to talk to it on a really low level, and there's a little helper class that makes this much more convenient, and that's the NS persistent store coordinator class. This is the thing that talks to the persistent store and saves your data for you. Technically, you're kind of talking to the managed object context to do that, which on our behalf is talking to the store coordinator, who then coordinates these low-level save commands. I know this sounds really complex, but the reason why this happens is because you could have more than one physical store file, and rather than having to talk to multiple, you just literally talk to one, which is the store coordinator, and it then coordinates where does that file live, what format does it have, how do I need to speak to the individual formats, and all you need to do is just talk to the store coordinator, if anything. In order to organize your data, you need something called the data model. And I had great difficulty understanding what the hell that is. And the data model in Xcode is a graphical helper thing, an interface that lets you create entities with attributes. And entities, you can think of them much like standard NS object classes, and attributes, you can think of them as properties. So you may have an entity that's called a book entity, and a book can have a title and an author and a date of release, and it can maybe have a Wikipedia URL, and it can even maybe have binary data like a cover image. And so the book would be your entity, and all the other things like title and URL and the binary data, all those are attributes. And we're going to learn much more about them in several videos down the line. And then there's one other thing that Core Data has, and that's called the NS Fetched Results Controller. And this class only comes into play when you're dealing with table views. So the Fetch Results Controller is not needed if you're not using Core Data for table views, for UI table views, let's say on iOS. It makes your life easier to query the underlying data structure of how many sections do I have, what data is in which cell. You can even insert new items into your manage object context, and the fetch results controller gets updated automatically, and you don't have to worry about it. Well, that's a lot to take in, and right now this is just all theory, and there's no real practical application here. If you've not heard of Core Data before and you're presented with these 6 magic keywords, you think, okay, so now I have some data, where's the frickin' save button? And that's what we're going to look at in the master detail template. We're going to have a quick look at Xcode 5.1 together with iOS 7.1. We're going to briefly use the iOS simulator, but all we're really going to do is we're going to have a peek in the vanilla master detail template, and we're going to have a look where all these things live and how you can talk to them. We're not actually going to use them, that's for another video. I'm going to create a brand new Xcode project here. It will be under iOS application, the master detail application, master detail template. I'm going to tick the Core Data box down here, very important because of course we're going to use Core Data. I'm going to use it for iPhone only to get rid of the clutter, and I'm going to call it CD language. We're not actually going to do anything with it. Put it on my desktop. This is just so that I can show you where all these scary classes are hiding that we've just talked about. If you've never run this before, which I'm sure you have, let's just run it and see what it looks like. This template is really designed for you as a starter template. So all it does is there's a plus button here. Whenever you hit it, an NS date object is created and saved in Core Data. The magic behind it is if you were to close this app and reopen it again, all your data is still there. Whoop-de-doo. Clicking on this only really displays the NS date object as a description. That's all this does. But the good thing is Apple have set up everything that you need to get started with Core Data. The first thing we're dealing with is the managed object. So the NS managed object gets created in the master view controller. There's a couple of things here in the header file. You have an NS fetched results controller. This is just because this is a table view, and we're not going to be dealing with that in this video. But the more important thing is that this class has a public property called the managed object context. This comes straight from the AppDelegate, which creates it, which sets it up via a custom initializer, and then passes it on to the master view controller. In the implementation file, well, first thing I want to do is Shift Option Command and left cursor to collapse all the methods so that we get a little bit more clarity into this rather complex looking, intimidating class. It's not actually that intimidating. If you know your way around table views, then you know a lot of what's going on here. There's one method here. It's called insert new object, and that's the one that we're going to be dealing with. Just so that you know where this gets called before we go through this code. In view.did_load, they're creating an add button in code, which is the little plus thing, and as soon as you hit it, insert new object gets called via a selector. So insert new object, what does that do? This is a slightly convoluted way of setting it up, and I probably wouldn't do it that way, but it's Apple and it's a template, and they're doing it slightly differently. So they're creating a new context, and they're giving it self fetched results controllers managed object context. I really don't know why this step, you can think of it as not there really. This one's much more interesting. NS entity description, entity, we're getting that from fetch results controllers fetch request. This doesn't make sense to you at the moment, but that doesn't matter. Just remember we're getting an entity here. The entity is the name of the entity that the data model takes care of for us. We need that in a second. So here we go and create an NS managed object called new managed object. But also notice that in here we're not calling alloc and init on this class. We're saying NS entity description insert new object for entity for name entity name. And this sounds bizarre, but what we're saying here is we want to create a new managed object of this entity, because you could have several entities. We only have one because this is just a template and a starter thing, so we only have the one, but which we're taking from the fetch results controller, because that's displaying all our entities, which are our date objects here. And we're also going to create it not just in limbo anywhere, we're going to create it in a concrete managed object context. So the managed object context, in our case, it's context. It could just be self-managed object context because we do have a reference to it in this class. Just in case we don't, this is how they're doing it here. They're saying context, they're taking the context from the fetch results controller, not strictly necessary because we already have a reference to self-managed object context. So this is our new managed object created. This isn't saved anywhere. This doesn't have any values. The value we're going to set next. So we're going to say new managed object, the thing that we've just created, set value nsDate, which is today's date and time right now, for key timestamp. They're doing this without even, they're explaining this in the comment here even. If you had a managed object subclass, you wouldn't have to do it this way. You could just call your class dot value equals the value, dot notation like in any other object. We're going to deal with that in another nugget, but in this case you can also just know that you can also use key value coding, and that's exactly what they're doing here. They're going to set this value, just a new date, to a key of timestamp. This is something just to remember, timestamp. Just make a mental note of that. We're going to come to that in a minute. Now that our managed object has a value, we're going to save it. And really all we're doing is, on the managed object context, we're calling the save method. There are other ways to do this, but in this case they're calling the save method straight on the context. And that also takes an error object, and in case there is an error, we're going to stop the program here. And we're going to write the error out. So empty error gets created if this operation returns not nil. It means we have an error, then we stop, otherwise everything's cool. That's our managed object created, and the rest of it is literally just the table view, so we're not going to go through that. What is more interesting here is two things. How does this managed object context get created, and where does that entity description come from? I don't know where we're going to start with this because they're all interlinked. It's difficult to bring order into this rather complex topic. Let's perhaps go back to the timestamp, and I'll explain to you where that came from. If you're creating a new core data project, you have this little class here. In our case, it's called project name.xcDataModelD. And you think, funky extension? What's up with that then? This is a little bit like I explained earlier. This is a little bit like the storyboard. So if you click one of those, a new interface will open up. Much like when you click a storyboard, a brand new interface opens up and you see all kinds of other things here, like graphical representations of your view controllers. But really, as we've already learned, this is just an XML file. When you click it, Xcode displays it in a sort of palatable way. But behind the scenes, when you actually run the app, this isn't what your iPhone runs. It's an XML file that gets translated into something much different that the iPhone or the iPad or iOS can understand. And it's the same with the XC model D file here. We'll just kind of call it the model file or the model editor file, I guess. And it's a whole new class in itself. I'm going to introduce you to this in another video. Right now it's important to have a look on the left hand side here under entities. We have one entity here called event. And this one entity has one attribute, which is a type date attribute. So you have several types of attributes. You can't save literally everything in them. They have to conform to specific types here. And the attribute is a timestamp. And timestamp is exactly the same value that we've just found in our master view controller when the new object got created. So if you were to try and put anything else here, set value for some other key, like something else, and we'd run this app, you'd get an error because something else doesn't exist on this entity. This entity currently only knows timestamp, and if we give it anything else, that'll just be an error. Likewise, if we try to pass a string value into timestamp, that would also be an error because the type is clearly date and that gets saved slightly differently. I better make that change this back to timestamp in case we do run this again. So, but what's up with this magical manage object context and the persistent store coordinator and all that? Where does that come from? Well, that, children, comes from the AppDelegate. Well, in this case, it's set up in the AppDelegate. It's a clever place for it to live. It doesn't have to be. And the good thing is if you start from a template, it's kind of all there and it's accessible from any other class. That's kind of the reason why it is in AppDelegate. If we look at the header file here, we have UI window aside, we have a NS manage object context called manage object context. Very good. We also have an NS managed object model, which is cleverly named managed object model. And the third thing that's also public is the NS persistent store coordinator, cleverly named NS persistent store coordinator. We're ignoring these two methods here for now and go straight into the implementation file and see how these things get created. Here they get synthesized. Oh, it's cute, isn't it? It doesn't really have to happen anymore, but hey, not to worry. First of all, we're going to collapse all the methods here with Shift, Option, Command, Left cursor. Bring a bit of clarity back into this. Now let's have a look at did finish launching with options first. And this is how the manage object context from the AppDelegate gets passed into the master view controller, at least in the template it is. So we're grabbing the navigation controller by saying self window root view controller, casting it to a navigation controller, and that top view controller must be our master view controller, and we're just handing our own manage object context to the master view controller's manage object context property so that we can use it there as well. Now that happens here. That is how our master view controller actually ends up with that property or with that value. It's happening here in the AppDelegate. Let's close this method again and have a look at the custom initializers of all our three manage object context, model, and store coordinator. There's a pragma mark here called core data stack, and this is where these three custom initializers are hiding. Here's the manage object context, here's the model, and here's the persistent store coordinator. Now, it's really difficult to decide which one to start with because they all rely on each other, and one calls the other, one sets the other up, so none of them exist in isolation. Perhaps we'll start with the managed object model. As custom initializers go, if we already have a variable, if that is not nil, just return that. If that's not the case, let's set one up. We're grabbing a URL, model URL, from our bundle, main bundle, and the URL for resource, it kind of depends on the title of your project. This is how this is set up, but of course you can of course change that. In this case, it's saying we're going to grab a URL for resource called CD language with the extension MOMD. As you recall, we didn't really create that. I don't recall setting up an MOMD file, and I certainly don't see one here. And that's because at runtime, this XCDataModelD file gets turned into an MOMD file. So here we basically call alloc and init with contents of URL model URL, and then we just return that. So this is fairly simple, but it's important to understand that this file you don't create. Xcode does this, or more to the point, the compiler does this on your behalf as soon as you run the app. As soon as the bundle is created, this thing no longer has any meaning, and instead we're having an MOMD file with which the managed object model is created. All right, that's the model. That's how this ends up in our app. Let's have a look. You'd think we're going to go to the manage object context next, but no, let's go to the persistent store coordinator. This is a really important class, and please don't get upset when I open this and you see all that. One thing I'm going to do is Apple are very kind and explain to you what you can do in case of an error in this massive comment block here. I'm going to collapse this to make it look a little bit less scary. There we go. So, just like all the other custom initializers go, if we already have that, just return that. And if we don't, let's make something. A little bit like what we had in the model, in the object model here. We're going to create a store URL in our own documents directory. There's just a little method here that gets called down here that returns the URL for our documents directory, onto which we append a file name. In this case it's called cdlanguage.sqlite. You can name it anything you want. The extension and the file name really doesn't matter as long as you take care of it. Xcode names it just like your project is named. So in this case cdlanguage and .sqlite, because we're using the SQLite format. So that's just a URL. Error object, empty error object, because now we're going to add that to a new persistent store coordinator file. So NS persistent store coordinator variable, we're calling alloc and init with managed object model, which is the one that we've just created, self managed object model, that gets set up in the previous custom initializer we've looked at. And this method, yes, this is difficult, but you will be dealing with this a lot, so pay attention here, kids. Really, we're saying to that newly alloced and initted persistent store coordinator, add to us a store file with the type of NSSQLite store type. This is an enumeration. You can have different values here. Configuration is nil. That's good. That we're going to deal with that much later on. URL we've just set up. Options also nil. Also very important thing here. That holds the key to a lot of core data shenanigans. And we're going to pass it that error, the empty one up here. If all goes well, nothing happens, and we're just returning the persistent store coordinator. If something goes wrong, we're stopping the app and we're telling the user, well, we're telling the log what went wrong. It's important to understand what's going on here. We're basically just saying alloc and init a new persistent store coordinator, and to it add that file that we've just created here. Random URL, just the thing in our documents directory, so that we can save files with it. Also important to understand is we're using the SQLite store type. Case closed. Return it. We've done it. This thing is huge, so over time you will get very much acquainted with this method and what you can do with options and configurations here. So now our persistent store coordinator has one file that it can use for reading and writing data to and from. All that remains to be looked at now is the managed object context, the star of the show, aren't they all? Well, let's have a look. If we don't already have one, create one. Interestingly, we're grabbing a coordinator here, self-persistent store coordinator. I don't know why they take this out. It's like saying 5 plus 7, and rather than just saying 5 plus 7, you split it up into 11 values, and in the end you just arrive at 5 plus 7. It's just more code. It really doesn't have to work that way because we already have self-persistent store coordinator. So why create another thing that's called coordinator? Random. Anyway, we're adding our self.persistent store coordinator, really, that is all it is, to our managed object context. That's all we do. So we say alloc and init on the managed object context, and init with the method that sets the self-persistent store coordinator. So now the context knows about the coordinator and the context know about the model, and we're kind of ready to start saving our values. So if we go back to our master view controller implementation file just briefly before we finish this here, this method, save, will, via the persistent store coordinator, save whatever this timestamp is to the file that we've just created in the AppDelegate, in the store coordinator. So as soon as that happens, that save method is called on the context, something gets written to this file. And that is how core data can remember and recall and bring back and query all kinds of changes. You may be wondering, well, why is this so utterly complicated? Does it really have to be that way? And the quick answer to this question is yes, really, because it's infinitely extensible. And as you look into core data more and more, people want to do more and more stuff with it. And you know what? Core data is ready for it. You could have two stores. One of it could live in iCloud. One of it could be a read-only store. Another one could be the store that people write data to. You could give pre-populated stores out with your application that your application reads from, periodically perhaps updates stuff to the internet from. It's big. Core data is huge, and this is just a brief introduction of the core data language and where to find that in the master detail template. I hope this was helpful. This was just an introduction. There are many, many more core data nuggets to come, and I hope you've enjoyed it. If you did like it, share this video with friends, family, and total strangers. Don't forget to subscribe to my channel, and bye for now. See you next time. Oh yeah, PS, don't get overwhelmed. Core data is easier than it looks. Bye.